Hey everyone, my name is Sebastian, and I'm the co-VP of Engineering and Cardano Project Manager at Emergo, one of the companies behind the Cardano project. In this video, I want to talk about the two upcoming hard forks to Cardano. One of them is called Allegra. Let me just write that down for you. Come on. Allegra. And the other one is called Mary. So as you may remember, right now we're in the Shelley era. We entered the Shelley era earlier this year. Now we're planning to start Allegra in December. So that's when the hard fork will happen. So it should be in less than a month from now. Mary comes afterward, and that one should be sometime in Q1 of next year. So in this video, I'm mostly going to talk about the Allegra hard fork, but these hard forks actually are kind of combined together and they work together. And so I'll also be introducing a lot of the features that are going to come in Mary, and I'll give you a lot of context for why these features are happening for Allegra, and it'll give you a heads up of what's to come for Mary so you know what to do. So this video is going to be fairly technical. It's mostly made for people who work on wallets or exchanges or tools that use Cardano and who want to know how they need to upgrade their systems to support these two upcoming hard forks. So first I'm going to describe briefly what is Allegra and what is Mary. What features do they add? Okay, so Allegra is mostly about a token locking logic, so token locking. And the reason we want token locking is because Cardano has a different project called Catalyst. And Catalyst happens independently from these hard forks. So it's not related. If you're an exchange, don't know what this means, you don't have to worry about it too much. But it's basically a treasury for Cardano. And it happens on a separate blockchain. But to vote for Catalyst, you will need to lock your tokens on mainnet, and then you can vote for treasury proposals on the Catalyst chain. And so to facilitate this, we needed to add a token locking mechanism. Okay, so that's what Allegra adds. And Mary, on the other hand, adds support for multi-asset tokens. And so what that means is that on Cardano, you'll be able to create new tokens that represent, NFTs, or maybe represent the state of some game. So you can have a blockchain-based game where, somebody earns tokens to represent some points on the game or currency on the game or something similar. So it adds this kind of multi-asset support. Now the thing is that, as I mentioned earlier, a lot of the things we need for multi-asset support will be added to Allegra, and these features will be disabled. And so that's why these two hard forks kind of work together, because Allegra introduces a lot of the functionality we need, but just keeps it disabled until the Mary hard fork comes in and adds the last parts that are needed. Okay, and so I'm going to go into a bit more detail now about who actually needs to care about these upgrades. So I'm gonna describe more about what these hard forks actually mean at a protocol level, at the binary level, and so on. But to save a lot of people time, now that you have a basic idea of what these hard forks add, I'm going to tell you who needs to upgrade. Okay, so let's just put that over there. So if you're a library that needs to create transactions, you don't have to do anything. Okay, and the reason I mention this is because, as you'll see later in this video, everything for creating transactions is backwards compatible. That means that the new fields added are optional. So all old transactions will still be valid in the Allegra era. Okay, so this is talking about Allegra. So in Mary it'll be different. If I'm talking about Allegra, you won't have to change your transaction creation logic. All old transactions in Shelley will still be valid transactions in Allegra. Okay, if you're using a tool called dbsync, Cardano dbsync, you will need to upgrade the Cardano dbsync but that's about it. Okay, so because the old transactions are still valid, if you don't care about the token locking mechanism or these kind of new features, the old stuff will still exist. It'll still work the same way. So the upgrade should be mostly painless. It should just be updating Cardano UBSync. For Cardano Wallet, which is a tool used by Daedalus and multiple exchanges, you will also have to upgrade. And again, it'll introduce the new features related to Allegra, but hopefully it should be a fairly painless update. And obviously, if you use the node, you need to update also. And then if you use our Rust library, the Emergo Rust library for Cardano, you can upgrade if you want to. We'll have a new version of our Rust library that adds support for these optional features. But if you don't care about these new optional features, you can just use the existing version and you don't have to worry about it. Okay, so this is a brief overview of who has to update. From a user point of view, it'll be entirely transparent. The user won't have to migrate funds or get used to a new feature. It'll be fairly transparent. And so there's fairly low risk of this hard fork introducing downtime for people who upgraded their nodes appropriately. Okay, so now let's go into more detail about what exactly happens at the binary level. How does Allegra actually change the protocol? And to do that, I'm going to show you some resources that may be useful for you, and I'll link them in the description of this video. And so I suggest you go over them yourself afterwards, but I'm going to go over them in this video and explain the differences in details. So as you may know, Cardano has a binary specification that describes exactly how the protocol works at the binary level. And so there is a existing documentation for the binary specification for Shelley, and I'll have a link to that in the description. And there's a separate file called Shelley.MA, which stands for Shelley multi-asset. Okay, and so if you want to know the difference between these two protocols, you just need to compare these two files. Now, Shelley is what we have now. Shelley.MA introduces both the Allegra feature and the Mary feature. So that's why I'm introducing both of these hardforks at the same time, because the binary spec includes both of the changes. And that's why I said that Allegra introduces features only required in Mary, but keeps them disabled. So let's go over the binary spec together and talk about the specific changes. Okay, so the changes are mostly in the transaction bodies. So the blocks themselves don't really change. It's mostly a transaction level change. Okay, so the first change I want to talk about is the time to live. So in Cardano right now, since Shelley, every transaction requires a time to live, and it's specified in a slot number. And if the blockchain move is past that slot, the transaction can no longer be added to the chain. Okay, so like if you say slot 1000, the transaction has to be put on the blockchain before slot 1000, or it'll no longer be accepted. Okay, so time to live used to be a required field. It is now optional. That's what this exclamation or question mark means right here. It means it's an optional field now. The reason it used to be required is that we had plans for Cardano to add a system where the refunds you get for pool deposits or staking key registrations would depend on how long they were stored on chain. But that idea hasn't been implemented, and may be implemented later. But in the meantime, we made time to live optional. Now, I still recommend that wallets and exchanges use this functionality anyways, because it makes it easier to debug user issues. So one thing that could easily happen is a user comes to complain saying, hey, I sent a transaction through your wallet or through your exchange a week ago, and it still hasn't appeared on the blockchain. What should I do? If you use the time to live feature, you can know for sure that, if it's been a week, there's no way it's going to make it on the chain. But if you don't use the time to live feature, it could be in the mempool, still there, or maybe stuck somewhere on a node that doesn't have an internet connection. It could still make it on the chain in the future, right? So to avoid this possibility, I suggest you still use the time to live feature, even though it is now optional. Okay. one new feature that gets added is a start interval. Okay, so the time to live was the last point at which the transaction can be accepted on the chain. The validity interval start is the first point on the chain where the transaction can be accepted. Okay, so this creates what they refer as the validity interval. So any time between the start and the end is when the transaction could be accepted on the chain. Okay, and note again, this field is optional. The reason this validity interval start is useful is for Plutus smart contracts and also for the token locking mechanism I described earlier. So the way that smart contracts work or will work in Cardano once they're released is that they're going to be stateless. Okay, and that means that you don't have access to the current block number inside the smart contract. And so the only way the smart contract that gets executed knows what time it is by looking at this time to live field and this validity start interval. And the smart contract will know, okay, I'm between these two times somewhere. So that's why it's useful for Plutus. It's useful for token locking because when you lock a token, you say, I want to lock this token up until, slot 1,000. After slot 1,000, it'll no longer be locked. Okay, and that means to unlock the token, you need to make sure that the validity slot interval is larger than 1,000. Okay, so if you lock your token till 1,000 and then you want to unlock it, you could make a transaction where the validity start interval is 2,000, and then for sure the node knows to accept this because it knows that by that time the token will, the ADA will no longer be locked. Okay, so that's why it's used for both Plutus smart contracts in the future, and it's also used for this token locking mechanism. And again, it's an optional field. Okay, next field I want to talk about is this mint field. It's again optional, and this is a way to create or destroy custom tokens. So as I mentioned before, the Mary hard fork adds custom tokens. And that means that to create custom tokens or burn custom tokens, you have to use this mint field. Now, Allegra doesn't add multi-asset support. And so because this field is optional, it'll always be empty. So if you see in the specifications, mint or forge, it's talking about this field. And note for the Allegra hard fork, you could ignore it. It's always going to be empty. Okay, but starting in Mary, this field could exist, and that's how people will create or burn custom assets. Next one I talk about is the transaction output. Transaction output, you might notice, is now uses something called a value. Okay, whereas previously, if you look at the Shelley spec, it used to be a coin. Okay, so a coin here represents ADA. Okay, only ADA. A value represents ADA and other tokens. So it's no longer just a single value, it's many values, including ADA. So for the Allegra hard fork, this will always be equal to coin. So value equals coin in Allegra because we don't have multi-asset yet. In Mary, we will have multi-asset values. And so that's when you'll have to worry about this. But again, for the Allegra hard fork, you can just assume value is the same as coin everywhere. But the reason I point this out is because in the specifications, you'll see the word value and coin used. And so that's the difference between the two. So that means that the transaction output field for Allegra stays exactly the same. No need to change anything. Just keep in mind that this field will change once the Mary hard fork will happen. Okay. Now the Allegra hard fork adds two new script types. If I just scroll down. Yes, here. So the Allegra hard fork adds two new kinds of scripts to Cardano. So Cardano already supports some native scripts that are useful for multi-sig. So Cardano supports multi-sig not inside wallets yet. Wallets don't implement this yet. But at a node level, you can actually already create a multi-sig wallet in Cardano. And so we already had some scripts that were useful for multi-sig creation. And we're adding 2 new scripts. They're called timelock start and timelock expiry. Now these names will change since making this video. I think the name will change to, actually I can't remember off the top of my head, but probably if you look at the specification, again, in the link to the YouTube description on this video, the names will have changed slightly, but it's the same meaning. And basically this is a way for you to specify when a token can be used, or when ADA can be used. And it's used for locking your tokens, again, for Catalyst. So you don't have to worry about this if you're an exchange or a wallet that's not supporting Catalyst. You don't have to worry about the token locking. So don't worry about it too much. And the next thing I want to mention is transaction metadata. So transaction metadata is used in Cardano already, and it's a map from some unique label, or not unique, but a label for a standard to some sort of JSON-like object. Okay, so wallets don't really use this right now. A lot of community projects use this. You know, for example, one community member is running an Oracle using transaction metadata by adding Oracle price feeds inside transaction metadata. We've seen a few people do on-chain voting by adding ballots into the transaction metadata. And people who use these kinds of standards will need to keep in mind that the transaction metadata is changing in Allegra. Now this is not a breaking change, because the way we're changing the transaction metadata is that it's either the old format, or, that's what this slash means, or a new format. Okay, so if you're parsing transactions at a binary level, you will have to upgrade. So, you know, Cardano DB Sync, Cardano Wallet, Cardano Node, and so on will have to upgrade. But if you're just creating transactions, you can still create transactions using the old transaction metadata format, and everything will still work. The reason we're changing the format is because we want to add the ability to add the code for a smart contract into transaction metadata. Okay, so if you look at the new definition, we have either general transaction metadata, which uses the same format, right? So just general transaction metadata, or you can specify a script inside the transaction metadata. And this is useful for projects where they want to share code of a smart contract at the time it's created. And this can be used to communicate smart contract code between applications. Okay, so you don't need to worry about this unless you need to actually use this functionality. But for most people who use transaction metadata, you can keep using the old format. If you want to upgrade at some point, use the new format. You can do that anytime. Cardano DB Sync does support transaction metadata, but if you're consuming Cardano DB Sync data, the table won't change, the data will be the same. So you don't have to worry about any break and change. And I think that's basically it for the binary specification. Again, you'll see stuff like multi-asset, which we'll talk about a policy, an asset name, and so on. But this is all for the Mary hard fork. And so the way it works is basically when you create a new token on Cardano, you have a smart contract that dictates how the token is created and how the token is burned. The policy ID is the hash of your smart contract. And every smart contract that can create and burn tokens, it's called I believe it's a forging policy script. Let me just double check the name real quick to make sure I don't get the name wrong. Yeah, so a forging policy script are the special kinds of smart contracts that can create or burn tokens. And the hash of these smart contracts is the policy ID. Now these forging policy scripts can have multiple tokens. So for example, you can imagine a game where inside the game you have wheat and meat and a bunch of resources. These can all be managed by the same forging policy script. And so you can think of these like a namespace, and inside the namespace you can have multiple assets inside it. So the reason it's a map of maps is to allow this kind of nested layering with namespaces for, you know, for example, a game that has one namespace for the game, which is the policy ID, and then multiple assets for this game, all managed by the same script. So that's mostly the description of the binary specification. If you want to see how these fields interact with each other, there's a document published by IOHK, which is a formal specification of Cardano Ledger with native multi-asset implementation. And this basically, in prose and in some figures, describes exactly how the ledger itself will handle it, and it points out the differences between Shelley and Mary and Allegra. So you can see this basically goes over the changes I described. So an output for a transaction is no longer an address and a value, no longer an address and a coin. It's now an address and a value. Remember, coin is just ADA, value is ADA and other currencies. Okay. And then remember that the Allegra hard fork introduces some new scripts, and the Mary hard fork introduces forging policy scripts. And so, they're saying that there's going to be some new script types, and that's the section yellow. We saw the min field added. We saw the validity interval with a start field and so on. So if you want to get a more understanding of how these binary spec changes get taken into account by the protocol, I suggest you read through this document. It's not that long, and it'll give you a better idea of exactly how it all works. I'm going to give you a summary of this document in just a minute. So if you don't want to read this whole document, but you want to understand the 10-minute summary, I'll explain to that after I finish introducing some other document. If you want to understand how the forging policy scripts work, so you're watching this video and you would like to create your own token on Cardano, there's a document called UTXO-MA that describes exactly how these scripts will work at the smart contract level. So notably, if you go down to page 9 or 10, so page 10 describes all the functionality available from these scripts. So these forging policy scripts are not full Plutus, they're not full-fledged smart contracts, they're a subset of the smart contract language. And they have access to only very specific helper functions to enable you to easily create and destroy custom tokens. So inside this document at page 10, you'll see a description of all the functions. I think at page 9, you'll see a more mathematical description if you're into that. But so at page 10, you'll see all the commands available. And then in section 5, which is the section right afterwards, you'll see multiple examples. So if you're watching this video and you're interested in Mary, you want to learn how to create custom tokens and what possibilities are available, I suggest you go to this document, skip the start, and read page 10 to see how it works, and then read section 5 to read through the examples, see what's possible, and then if you're interested in use cases this allows, then you can go back and maybe read the document to get a better idea of what's going on. And so before I do the last part where I summarize the specification changes, I just want to say if you're Cardano DB Sync user, keep track of this pull request that adds Allegra and Mary support. If you're a Cardano wallet user, check out the releases for Cardano wallet. There's no release for Allegra or Mary yet, but definitely check out the release page. If you're using the Rust library for Cardano, then definitely check out the Cardano serialization lib, and we'll update our Rust library to support Mary and Shelley fairly shortly once we just update the binary spec. So I just want to mention the link to all these pages will be in the description of this video. So if you're an exchange and you want to know, when is this released, when can I start upgrading my systems to be ready, check out the description of this video. I'll have these 3 links. Now, last thing I want to do in this video is just summarize this document real quick, so you don't have to read the full thing. But obviously, if you really want to know how everything works, I'll have a link in the description, and you'll get a better idea of, how this all works together. So let me just pull up my notes real quick. Okay, so some things I already mentioned. The UTXO value is no longer a coin. It's now a value field, which represents a coin plus multi-assets. And so a coin will be required. You will need to add ADA inside UTXO outputs. And that's because there is a minimum UTXO value per UTXO in Cardano. So remember, in Shelly, we defined a new minimum value for UTXOs as 1 ADA. So every UTXO entry you create has to have at least 1 ADA in it. This concept will continue, but it will change slightly in Mary. Okay, so that means that every output you create starting in Mary will no longer have to be 1 ADA, but instead a variable that depends on the size of the output. And the reason we did this is because a UTXO value can now contain multiple tokens. The size in bytes changes depending on how many tokens you add, right? So if you create a UTXO that's only a Cardano value, it's fairly small in number of bytes. But if you create a UTXO entry with 20 tokens in it, it obviously takes more space on the blockchain. And so to take into account this new variable size of UTXO values, the minimum value you need to put in a UTXO will change to a variable formula. Okay, so inside this document, you'll find a bit more information, but basically it'll be a protocol parameter that can change over time. Same the way the minimum value right now is a protocol parameter that can change over time. And so once the Allegra hard fork happens and the Mary hard fork comes around, probably you'll hear about the concrete value used for this parameter, and you'll be able to update your code accordingly. But just so be aware that the 1 ADA minimum value will be disappearing and replaced by this variable function. Okay, and then I think everything else I mentioned in this document was already mentioned when we went over the binary spec. So we mentioned, transaction metadata is changing, mentioned the new validity intervals and so on. And so I think the minimum value changing was the only main thing that's added to this document. So obviously everything I mentioned in the binary spec is here, so if you want to get more information, definitely read through. But I think that's the last thing in my notes that I want to summarize. There are some definitions that may help you that are inside this document. And so you may hear in some places the word asset and the word tokens. These are not quite interchangeable. So this is kind of a naming mishap where, as I mentioned, a multi-asset is a 2-level map, right? So remember we had the policy ID to the asset name, right? So remember it's a 2-level map. So in some places you'll see the word asset referring to only this component, and token referring to the combination of policy ID and asset name. So if you see the word token or asset, you have to figure out, depending on the document, the naming slightly changes. And so you have to figure out, is the token referring to the combination, this pair, or just the asset name? There's also some documents that use the terminology asset ID, but that was changed in the future to asset name. So if you're reading the documentation I have in the description, you see the word asset ID. Keep in mind that this was changed to asset name. In some documents, you'll see asset ID refer to the pair, but that's now called a token. So slightly unfortunate that names have kind of collided over time. Different teams have different naming conventions. But I just wanted to point this out because depending on the document, the way what they call a token, what they call an asset slightly changes a bit. So if you read through the UTXO-MA spec and you read through the ledger spec, just keep in mind that the definition for the term slightly changes. And so I just want to point that out to you. And that's all I had. Obviously, I'm still reachable on Telegram, on Twitter, and so on. So if you've watched this video and you still have questions, reach out to me at any time. IHK will put up more information on these hard forks going forward. Definitely follow IHK and the Cardano Foundation on Twitter, on social, to get their updates. And there's going to be some more news as the Mary hard fork approaches. For example, you'll notice when I talked about the multi-asset standard, I didn't talk about a way to give a actual human readable name to your tokens, or how to specify the supply of the token, or this kind of information that's important for explorers to show. And that's because there's going to be some metadata server proposal that gets put out in the future. So what I've gone through in this video is what is available now, but there will be some more details fleshed out as we get closer to the Mary hard fork. But everything for Allegra is mostly fixed. So if you're watching this video, it should be true all the way up until after the Allegra hard fork, and then IHK may change some stuff for Mary. That's it. Thanks for watching this whole video, and hopefully this gives you a better idea of exactly what to expect and whether or not you need to upgrade at all. Thank you very much.